Welcome to the demo of the Biological Specimen Inventory System, or BSI, a product of Information Management Services. First, I'll show you a brief PowerPoint, and then I'll go into a live demo of the BSI system. A little bit about Information Management Services, or IMS. We were founded in 1973 and have been providing NIH with biomedical computing support for almost 40 years. We have approximately 200 employees, and we specialize in statistical analysis, systems development, and clinical trial support. Now about BSI. BSI has been in production since 1998. It is 21 CRF Part 11 and FDCC compliant, which means we are a validated system and can be installed on a federal desktop. BSI is flexible, configurable, and customizable, and extremely scalable. We have customers with under 5,000 specimens and customers with over 14 million specimens. BSI is used by a wide range of labs and repositories, including those in government agencies, universities, nonprofits, and Fortune 100 companies. BSI provides the ability to track biospecimen data and processes, including those related to storage, acquisition, and distribution. BSI will automatically track specimen lineage, freeze-thaw cycles, and other metadata, including full audit trails on any changes to the system data. In addition, you can also track subject, consent, study, and assay results data related to the biospecimens. BSI integrates easily with other informatics systems. BSI provides complete biospecimen management. Core BSI functionality includes the ability to manage storage locations so that you can easily find available space for new biospecimens. Easy data entry built for high throughput, tracking work orders and specimen processing through requisitions, the ability to track study and protocol data related to biospecimens, and of course reporting to get your data out of the system. Additional BSI capabilities include tracking subject and consent attributes. These attributes are also tied in with the biospecimen data so that you can search on the three in conjunction. And in fact, if you have a subject with consent issues, you'll be flagged when you pull specimens for a work order or requisition. BSI also allows you to manage collection kits, including kit supplies, kit inventory, and to send and receive kits from collection sites. You can also track new acquisitions and compare manifest values to actual specimens that you receive and note discrepancies and report those discrepancies with collection sites. The system will also let you track the resolution of those discrepancies. BSI also tracks analytic results related to the biospecimens. BSI contains tools and utilities that can be used throughout the system, including discrepancy tracking, barcode printing and scanning, data importing, data translations on import and scan, and data templates that create macros to ease data entry. So for one BSI system, you get complete biospecimen management. There are three interfaces to the BSI data. One is the BSI client. This is a Java client installed on your desktop that is the primary user interface for the folks managing the biospecimens. We also have a browser-based interface, BSI Web, that has a small subset of the functionality of the client. This is really for the occasional user, the PI that wants to check in on their collection or their work order, or the collection site submitting incoming shipments to the repository or lab. And finally, there's BSI Connect. BSI Connect is a web services API that allows for system-to-system communication. IMS also provides some BSI extras, including a data warehouse where you can easily report on business metrics related to your biospecimen data, BSI monitors, which allow you to create monitor reports to report on system status, and tailored customizations for you. The following enhancements are planned for 2012. BSI Satellite, where collection templates can be configured for collection sites, and sites can track their inventory before shipping it to the repository or lab. Upgrades to the BSI web interface. The ability for users to define specimen fields and edit checks via the BSI client. Enhanced requisition templates to represent and track complex specimen processing. Inline calculations, and additional statistical functions and reports. Now I will log into the BSI client and show you an example of a workflow for getting data into the system. We'll look at locations while we're doing that, and pulling specimens and shipping them out to an outside lab. We'll also look at reporting. So first I'm going to go ahead and log on. So the first page that you see when you log on is the BSI Home tab. We're on the demo database, and as you can see on the Home tab is news about new features and downtime. Next I'm going to go to Locations and show you some locations configured in the location tree here. So here's my repository. I'm under the demo repository, and I have a building and some workbenches, and if I expand the building I see some freezers, and if I expand the racks and the freezers I can see the boxes in the rack. If I click on the box, I can see a preview of the specimens inside the box, so we can look at a couple boxes. The data that you see here is chosen by the user and the user preferences. And there are some shortcuts that I can do to manage the specimens from in the box. So you can see if I right-click on them, there are a lot of simple tasks that I can perform on the specimens right here from Locations, and in fact anywhere a BSI ID is listed. So in the Locations module, you'd set up all of your storage locations, even your perspective space, so even your empty boxes. And this is how the system knows what space is available when you add new specimens, because when you ship something out or you empty something in the system, the space is cleared and a room is made for new specimens. So that's Locations very briefly. Now I'm going to go to Data Entry. So this is the Data Entry Manager. The manager contains all of the saved batches created by me by default. So this is all the new specimen data that I'm working on entering into the system. Once I have all the data in the batch for the specimens, and once there are no errors, I can commit this data to the database, and now the specimen records are available for reporting and for other folks to requisition to perform tasks on. So let me go ahead and click on this batch that I've already set up. I'm going to go to Edit. So this is the data entry editor. I've used a template to generate data that I expect from a certain collection. So for this study and this visit, I expect a whole blood, a plasma, 2 serums, and a Buffy coat to be processed before storage. I'll go ahead and show you how you can generate data using a template. So I picked my Generate button, and I can enter a subject ID and specify a date drawn and say Add Data. And you notice that all the specimens that I'm expecting to collect and process from that draw are listed in my batch with some default data. Now I can go in and I can add data for required fields and adjust any of the default data. So let me go ahead and use a tool called Mass Change to add this date received value. So we'll pretend like we received them on the 8th. So now that error is cleared because I filled in the required fields. Now let's say we didn't have enough blood to create this serum. If that's the case, I can just delete this record. And I can adjust any other data for the specimens I did collect or process. The next step in my data entry batch would be to assign the BSI IDs, which are our unique identifier. There are other fields in the system to track other identifiers, such as the current label or the original ID. But I'm going to go ahead and assign BSI IDs. I let the system pick which ones are available, and now they're reserved for these specimens. I can then go ahead and print labels. So we'll have to pretend that I'm printing them to the printer, although you won't be able to see that. And then finally, I'm going to add locations for these specimens. Now there's several ways to add locations. I could scan these barcodes as I'm putting the specimens in the box and have the system assign them. I could type in locations, but I'm just going to go and pick them and let the system fill in the locations, starting with the first specimen record down. So I went to Reserve Locations. It should look very familiar. This is my repository storage hierarchy that we saw in Locations. And I'm just going to pick freezer 1 and see what's available in that freezer. So I have one box available. Oh, it only has 4 empty slots. So let's go back and pick another freezer. There we go, that's more like it. I'm going to put my specimens away in this empty box. Now you could select different specimens and put them away, so you might put your whole blood in one place, your plasma in another. That's completely fine, but for the purposes of this demo, I'm just going to put them all in one box. I'm going to go to next. I can specify a fill pattern if I wanted to and a starting row and column, but I'm just going to let the system fill in the next available slot in that box. And I'm going to go ahead and say reserve. So now my locations are filled in and all of my specimen data is filled in and I have no errors left. I can save this batch and I can check the data against the database to make sure that anything I'm adding is not conflicting with what's already in the system. For instance, I don't already have specimens for this visit and this subject. It looks like I have no errors, so I'm going to go ahead and commit the data. So the batch is committed in the background. I can go ahead and do other things on the system. I'll get an email notification when my batch commits, and I'll get a message on the message tab. So now those specimens are going to show up in my box in locations. I believe I put them in freezer 2. Let's see if we can find them. So those specimens are now added to my box, and I can see them in my box, and they're available for people to pull for assays or to do further processing on and report on them. So that's data entry and a little bit of locations, and now I'm going to go to Requisitions. Requisitions by default lists all of the work orders, all of the work that is open for your repository or your lab. When a work order is submitted either from BSI Web or the client, the repository lab will get an email notification that they have a new work order, and they'll be listed here. The items that you see in red are either newly submitted items or items where someone has gone back in and changed the instructions or added specimens or added additional tasks. So I've already set up a requisition for the demo, and I'm going to go ahead and open it. So let's edit it, and I'll make the window bigger so you can see it. So this is the requisition editor. The editor contains the include column, which says the status of the specimen within the requisition, the vial status of the specimen. Notice that these went to reserved. Only specimens that are in your lab or repository can be added to a requisition, and once they are added to a requisition, the vial status goes to reserve, indicating that they are basically locked for this work, so that nobody else can pick them for other work until they're freed up. Then I have the tasks that I want to complete, my pull tasks. I want to verify that I've pulled the right specimens from the freezers. My ship tasks, and I'm going to ship them out to a lab. And then over on the right is a whole bunch of specimen data just for reference, so you don't have to do any additional reports or go to any other screens while you're in the requisition editor. So first, I'm going to complete my pull task. Each requisition task has a bunch of reports that are associated with it, and I'm going to print a pull vial report that basically shows where my specimens are in the freezer. So I can print this report, take my cart, pull my specimens, and come back. Now, if I had a nice scanner, I can actually download the pull report to a scanner and get confirmation at the freezer that I've pulled the right specimens. But we'll pretend that I pulled them, they're on dry ice, I'm bringing them back, and now I'm going to scan them. If they're barcoded, I can scan them to verify that I've pulled the right specimens. So this is the scan dialog. I'm just going to say scan vials. And I have some defaults set up for scanning, and I'm going to scan in the current label. Now I'm actually typing it because I don't have a scanner hooked up to this computer, but if it's scanned and matched, then it'll mark the scan column as true, so I can go through here and scan each one, and if you actually have a scanner, it goes very quickly. Now I just want to show you, if I scan in something that doesn't match, I get an error down here on the error table, and I can actually print this error table, and I may want to add this specimen that I pulled and I wasn't supposed to the requisition, just to indicate that it came out of the freezer and I'm putting it back in. So instead of boring you with my typing in all the current labels, I'm going to close this and show you that only the things that I scanned are marked as completed. So I'll go here. And notice only the pull task that I scanned is marked as completed. Now, I'm going to go ahead and mark the rest of these as complete. You can still have a pull task if you don't have barcodes. You just have to visually check and mark them as completed. So now my pull task is complete, and now I want to complete my ship task. But first, let's take a look at the ship task data. So in my ship task, when I set it up, I picked a destination, That destination is associated with an address and even an email. And I can type in a courier, or I can pick a courier, and I can enter a tracking number. I can even add attachments. I could, on completion of the ship task, have this lab automatically notified and have a packing slip sent to them. So this is all data associated with my task. I'm just going to say OK. Previously, I assigned a packing order to these specimens. Let me show you. I specified how they were packaged in the shipping box, and I actually had the system generate this. I can print a shipping manifest from here, and this is the manifest that is sent with that automated email to the receiving lab. So it just says, some information about my requisition and then some information about the specimens that they should expect, including that shipping order that I entered earlier. And now I can either scan to ship these out if I want to verify the order in the shipping box. I'm just going to mark this task as completed, that I've shipped them. And you'll notice that when the task completes, that the vial status will go from reserved to out, indicating that the specimens have been shipped outside of my lab or repository, and the requisition status will go to completed, indicating that I've completed all the tasks in this requisition and I have no further work to do. So that's requisitions, a very simple requisition, very quickly, but you can track a whole host of different tasks in different orders. In fact, let me just give you a little preview of the tasks that BSI can track. Everything from straight aliquoting to creating tissue microarrays, to withdrawing for assays, to shipping out to other labs. And we can even add custom tasks. Let me go ahead and cancel out of my requisition. So that's requisitions, and the last thing I want to show you is reports. So the reporting manager has people's directories on the left side and the contents of the directory on the report, but I can share reports with other users under my institution that are in my lab or repository. If they've created something I like, I can generate it from their directory and I can save it to mine. I can't overwrite what they've done. So let me show you a couple different types of reports. And actually, I'll go to the new. There's a whole bunch of canned reports that the system comes with, and these have a predefined look and feel, and we let users enter the search criteria, of course, to generate them. And then there are some user-defined reports, and I'll show you an example of a user-defined frequency to get counts, and a user-defined listing that lists one line per record that is returned by the search. And then the listing, you can specify the fields that are displayed, the order they're displayed in, and the sort. So I'm going to do an inventory report, a canned report. And on this general page, I can pick the output. I can enter a title that actually shows up on the output. And I can enter a search. So in this case, we'll do study equals demo and vial status equals in. So we want to see everything we have in for this study. And I'll go ahead and run the report. So just an example of a report output for a canned report. Here's my title that I added and the date and time that the report was generated, and the listing of all the specimens that I have for this study. Next, I'm going to run a frequency report. So this will give me a count. So I can do the same display. I can pick my output type. I can enter a title. I can pick what fields to display. In this case, I want to get counts by material type and vial status. So I want to see what I've collected and what's happened to those specimens. And then I'll generate a search, and I'll do the same search, study equals demo. So I want to see everything I've collected for the demo study and what's happened to it. So I'll go ahead and run the report. So this is an example of a frequency. You can see for this demo study, I've collected a total of 5,474 specimens. And I've collected some buccal cells, and you can see that I have 6 buccal cell specimens still in, and 1 that's reserved in a requisition, and 13 that have been shipped out. This frequency is actually a nice overview of what's gone on with the study. So that's a frequency report. The next user-defined report is a listing. So let me go ahead and open my listing that I have saved. Now this time I picked a comma to limited file as the output because maybe I want to open it in Excel, maybe I want to import it back into BSI, maybe I want to import it into another system. Again, I can add a title that shows up on the report output. I'll pick my display fields just by simply clicking on them and moving them over or clicking and dragging. In this case, I've picked current label, subject ID, material type, volume, and then some information about the location to display. And I can reorder these fields if I'd like. I can specify a sort order. Let's do by subject ID and material type. And then I can specify a search. In this case, I did study ID equals demo and vial status equals in. But I have a whole host of fields that I can search on, including those subject attributes that I defined. And we even give you all of the database tables that you can look through for fields to search on. Let's go back to my vial field. So here's my search, study ID equals demo and vial status equals in, and I'm going to go ahead and run the report. I'll move it over to show it to you. So here's the report, the listing of all the specimens that are available in the demo study, and here is the BSI ID or the current label, material type, and some volume information and location information. Again, I generated this as a comma delimited file, not as pretty as the PDF, but I can save it and I can open it in Excel, I can import it back into the BSI system, or I can import it into another system. So in this demo, we've covered one workflow out of many. So the tip of the iceberg functionality, getting specimens in through data entry using a template to generate the expected specimens, looking at locations and how we set up a repository and picking available space for the new specimens, a simple requisition to pull specimens from the freezer and send them out to a lab, and then finally some reports.